Well, hello everyone, and welcome to another episode with your girl Audrey Codner from GED Math Tutoring. A is for algebra, C is for college algebra, and G is for geometry. So, what we're going to do for today in our summer hours. Yes, I am normally at 8:30, but today I'm starting my summer hours at 7 p.m. A little bit late, little tech difficulties, but we are here. So for tonight, we are going to work on transformations of functions. That is what we're going to be looking upon. So if you are in college algebra or algebra 2, or if you're thinking about taking the SATs or the ACTs and any of those advanced things, well, put down the remote and let's do a little bit of math, shall we? All right. So when we're looking at the transformation of functions, we always have some kind of start, and that start is called the parent function. So with the parent function, it always gives us like a start of what the design or what the actual function is. It could be a linear function, quadratic, cubic, anything of that retrospect. But what we're looking at for today is the different types of shifts, and if we get to it, the stretch and the compression. So the key thing is, if it's happening inside of a parenthesis, that means you're going to have a horizontal shift. You're going to be moving from left to right. If it's outside the parenthesis, more of the tail end, like your K, your unknown, your constant, that's going to be your vertical shift, which is going to be up or down. So what we're actually going to be doing is let's kind of take a look at how the things move. And once you understand what the transformation is and how things move, you can do this for any function. Like I said, it could be for linear, it could be for quadratic, it could be for absolute values, it could also be for cubic. Those are the most famous ones. All right, but if you understand how things shift and move, you can apply it to any function. All right, so most of the times when you hear of the word transformation, and especially if you just finished geometry, there is 3 rigid transformations, which is translation, when you're basically just sliding, okay? Reflection, which is what happens on one side, will also be a mirror image on the other side, either the y-axis or the x-axis. And the other one is rotation. And the reason why they call it a rigid transformation is because it doesn't get super big or super small. It keeps at the same shape. So with that going through, then there was one other one called the dilation. So think about when you go to get your eyes examined. They like make your pupils get huge, right? Or even if you look at a cat, when a cat's like really ready to pounce, once you see those pupils get huge, back up, because she or he is about to claw the living hell out of you, and your arm's gonna look like a road map. Okay, so when you have the dilation, it's actually getting either bigger or smaller based off of what's called a scale factor. So when we take a look, I have a function that's already dealt right here, and I didn't want to pick one. I just wanted to kind of zoom in, just kind of keep it a little generic. But I'm going to show you how you're going to get your different shifts. So first off, if we notice, we have our endpoints. We have 1 point here, 1 point here, 1 point here, here, and here. So what we're actually looking at is we first want to get the point values, okay, of each of those sections. So right here, I'm at 0, 0. So that means that's -1, -2, -3 at -4. So what would be the value of -4? Let me shrink a little bit because I really want us to fill out our table. So at -4, it looks like we're down at -1. At -1, our y value is going to be at +2. At 1, our y value is also going to be at +2. 4, don't ask me why I skipped over. All right, and then at 3, it's on the x-axis, so 3 is going to be 0. So you notice that you see f of x. So since we're dealing with functions, our y values are going to be considered functions of x. So that's why sometimes you may see a y and sometimes you may see a f of x. But since we're talking about functions, I need to put f of x. But it basically means the same as your y value. Now, with that being said, what happens if I want to do a little bit of transformation? So let me shrink this down a bit so you can see what's going on. So I'm going to use this same grid, but this time I'm going to use, I'll use the red. I want to know what's going to happen when I have f of x plus 2. Okay, so if I want to know when y equals the f of x plus 2, okay, looks a little funky, but just roll with it. So I want to know what's going to happen if I want to move this function plus 2. What kind of shift, gotta emphasize that word, are we dealing with? Are we dealing with a horizontal shift? Or are we dealing with a vertical shift? Okay, good, Mars. We're going to move up 2. Good. So we're going to be going on a vertical shift. So that means all of my values are going to move up 2. Now, which value? Is it going to be the x value or the y values that's actually going to be doing the moving up 2? Okay, Miley's right in my brain. Okay, so if I have my, I'm just going to make it rather small. So we have our f of x plus 2. And we're going to use the same values because my x values are not going to change. I'm going to finally put the 3 where it's supposed to be. And there's the 4. So if up 2. So I'm here, I'm going to move up 1, 2. So my point should be right here. Moving up 1, 2. So my point should be there. This point should be here. Moving up 1, 2. This point should be here. 1, 2. This point should be here. So my graph should be something like that. But if we're looking at it, if I'm adding 2 to my original, because remember, this is going to be this is going to be my y values that I'm changing. So if I add 2 to -1, I should have a 1. If I'm adding 2 to the 2, this should give me 4. And if I'm adding 2 to the 0, that should give me 2. So if we take a look, -4, 1, that should be this point right here, which it is. -1, +4, 1, 2, 3, 4, that works. 1, 4, 1, 2, 3, 4, that also works. 3 goes up 2, 1, 2, and 4 goes up 4, 1, 2, 3, 4. So we can do the movement graphically, or we can figure out the movement in a table, which is called numerically. Okay. Well, good. I'm glad you like it. I don't know. Well, it's getting nice and warm out. Probably people are out. It's a Sunday. People are just relaxing. All right. So this is telling me if my outside or my constant is a positive number and it's outside of the parenthesis, that means it's going up. So let me see if I can use the same thing, but this time I want to say y is equal to f of x, let's say minus 3. So let me set my table up just for a moment. Okay. And then I got my f of x minus 3. So that means we have -4, -1, 1, 3, and positive 4. So if you're sitting here thinking like, all right, cool, we're going to start right here on the red, and now I can go down 3. No. Remember, it's saying the f of x minus 3. So the f of x is my parent function. So we're starting right back at that blue function that we have here. And from each of the points, we're going to go down 3. 1, 2, 3, making our point. So notice the x values doesn't move. The only numbers that keeps changing is my y values. So that means if I took my y's or my f of x off of the parent function and I subtract 3, so -1 minus 3, that gives me a -4. And then 2, okay, minus 3, that gives me a -1. And then the 0 minus 3, that gives me a -3. So here I am at -4. I go down 1, 2, 3, 4. There's my -4, -4. Then here I am, I'm going down 3, 1, 2, 3. I'm at -1, -1. And then I'm at 1, -1. Here's my 3 going down 3, 1, 2, 3. I'm at 3, -3. And then the 4 to -1. So again, you can look at it as a graph, or you can look at it as a table numerically. All right. So this is what's called a vertical shift. Okay, gotta put the T and the F in there, right? Okay, gotta put that F emphasis in there. So if it's positive, you're going to raise up. You're raising the whole entire function up. If it's negative, you're lowering the whole entire function down. And the only thing that changes is your y's, aka your f of x's. All right? So that's not too bad, okay? If you can understand the constant at the end does the vertical shifts, you can do this for any graph. You can do it for linear equations, quadratic equations, absolute values, okay, cubic, okay, any of those functions, if you understand it from here on in. So let's kind of do a little bit of venturing. So we did the vertical shifts. Let me get you ready for the horizontal shifts. So let me see it up. Okay. Okay, and while I'm setting up, if you can tap, that will be amazing. Because any kind of support I can get from you guys, that would be amazeballs. If you know of anyone that's thinking about getting their GED or thinking about going to the military and they need some assistance with the ASVAB, I am running some courses. Okay, this is the best time to get it, and this is like the last push to get into my courses. So if you know of anyone you want to share it, you can share this work. I would greatly appreciate it. Okay. Hello, Antonia. How are you? All right, good. Yeah, nothing too damaging. I know, it's a little different because I'm starting my summer hours, so I had to make the shift because, yeah, it's getting a little cray-cray around this time. All right. Okay, so, quick recap. If you have your constants, if it's outside the parenthesis, you're doing a vertical shift. If it's positive, you're going up. If it's negative, you're going down from the starting function. And the starting function's name is called the parent function. There you go. I just summed it up, right? So now we're going to be doing the horizontal shift. Horizontal means that we're going to be going along the x-axis. So if I may, I'm going to look at it from this perspective. Let's see if I can get, let's see if I can put my purple pen in there. See if I don't get too much colors mixed up. So this time I want the x plus 2. Now, this is the part that people generally get a little bit mixed up. So, I'm saying that I'm going to have from my parent function, again, I'm going to make my little graphs here. So, I'm still going to stick with my -4, -1, 1, 3, 4. And this time, we're going to be dealing with what's inside the parenthesis. So that means and I know for a fact, a lot of people are going to be thinking, oh, okay, all I have to do is just move 2 places to the right. Well, let's see. So before we start moving things around, let's see how things are going. So if I have my -4 and I plug it in for x, so -4 plus 2, that gives me a -2. If I do a -1 plus 2, because I'm substituting the -1 for the x, plus 2, that gives me a 1. If I plug in a 1 in for the x, 1 plus 2, that gives me 3. If I plug 3 in for the x, 3 plus 2, that'll be 5. And if I plug a 4 into for the x, 4 plus 2, that'll give me 6. So let's see if we can plot those points. So we got 1, 2, 3, 4. So we got -4, -2. Hold on, did I do... Okay, never mind. Oh, wait, hold on. I think I screwed up, which is a great possibility. So I got -4, -2. All right, thanks, Bam Bam. Trying to think what I did wrong. Because I was like, all right, this is my original function. And if it's supposed to be plus 2, I should be moving further along. So I think I substitute in the wrong spot. Because it really, well, right now my parent function is at 1, 2, 3, 4, -4, -1. But since it moved over plus 2, it should be going to the left 2. That's what I'm trying to show you guys. But for some reason, it's not showing that. So I screwed up somewhere. I have to figure out my table. But all I know is when I move 1, 2, I'm moving to the left. I always go opposite. 1, 2, 1, 2. Yeah, because my ordered pairs is not reflecting that. Because I just remember anytime it's inside the parenthesis, let me write this off to the side. It's opposite what you see. Okay, so if they give you x minus or x plus a number, let's start there. That means you're going to the left. If they give you inside the parenthesis x minus a number, that means you're going to the right. Okay, that means you're going to the right. Yeah, I think they're supposed to be switched. I don't know why I'm thinking weird. Because it's really supposed to be the X. I don't know why I'm thinking weird, guys. I'm sorry. It could be the heat. I don't think it's the heat, but I'll just remember, I know I have to work on this whole thing. But if anything, I know that anytime it's inside the parenthesis, it's always opposite what you see. So if you see a plus sign, you're going to the left. If you see a minus sign, you're going to the right. So like if I wanted to go, and I'm running out of colors, if I wanted to go, that's right, okay. So if I wanted to go, let me shift over a little bit. If I wanted to go to the f of x minus 3, we'll just keep with the 3 pattern. So if I'm looking at f of x minus 3, that means I'm going back to the parent function, which is my blue one, the one that's a little bit lighter. I'm going to go back to that parent function. Let's see if that works. Yeah, it's a little bit brighter. All right. And then I'm going, since it's minus 3, I'm going to go to the right 3. 1, 2, 3, make a point. Here's my other one. 1, 2, 3. So it happens to be there. Same as the one that's across from it. And then we have 1, 2, 1, 2, 3. And that's 1, 1, 2, 3. So I'm going here, here. I know it looks a little confusing because it's kind of like over top of each other, but there we go. That. Okay. Hey, Robert, how are you? Oh, the Feng Shui of 2. Yes, thank you, user. Thank you, thank you, thank you. It's just not registering in my brain right now. It's true. Okay. So, anytime you see that plus 2, you're going to go to the left 2 units. When you see the -3, you're going to go to the right 3 units. Okay? All right? So outside the parenthesis as your constant, you're going up or down. Inside the parenthesis, you always do the opposite of what you see. If you see a plus sign, you're going to the left. If you see a minus sign, you're going to the right. Oh. Yep, just keep fooling around with it. All right, now we have basically 1 more, maybe 2 more. I might be able to just do this whole segment in one spot because I think that all can happen. So now, where's my other one? Just around the riverbed. So now we did the vertical shift. We did the horizontal shift. Now we're going to get ourselves started on stretch and compression. So the part that tells you the stretch and the compression when it comes to, say, the formula, it will be your A value. So if I have, well, we know the regular parent function, but if I wanted to know when y equals 2 times the f of x, okay, the A value that I speak of would be the 2. Okay, sometimes we like to call it the leading coefficient. Okay, so the leading coefficient, that's going to tell you if it's going to be a stretch or a compressed. So if I may back up, if your A value is greater than 1, that's going to be a stretch. So if you think about it, it's almost like a person that's really tall. Their numbers are pretty tall, okay? So your numbers, like if you're compared to someone that's 5 foot compared to someone that's 6 foot, okay? Yeah, there's a foot between them. But it seems like the taller they get, the more kind of stretched out they get. So the bigger this number is, the more stretched it's going to be. Now, if your A value is between 0 and 1, not equal to, but between it. So I'm looking at 1/2, I'm looking at 1/3, I'm looking at 2/7. I'm not saying because it's a fraction. That's not correct. Okay, I'm not saying because it's a fraction, because I'm going to tell you that 7/5, like an improper fraction, that is going to be stretched. Okay, so the reason why it's stretched because 7 divided by 5 is more than 1. Okay, so I can't say, oh, if it's a fraction, it's going to be compressed. No. So if it falls between like maybe a proper fraction, like 7/2, maybe even 1/3, maybe even, I don't know, I'm thinking like 6/7, I don't know why, but that popped in my head. Okay, if it's a proper fraction, it'll be compressed. But if it is an improper fraction, or maybe a whole number that's greater than 1, it's going to be stretched. Stretched means it's going to be long and narrow. Compressed is going to be short and wide. So like if you step on a can, a lot of people think that it goes this way. No, you're pressuring the air out of the can. So it's really expanding outwards. So thinking of those things, it all depends on your A. Okay, it only depends on your A. So for this case, we're basically going to take our original, which I'm going to rewrite because I hate going back and forth, because that makes me a little nuts. So if I have... Okay, so if I have my original, so say my original was my x values, and we have our f of x, and then we had, oh, I love when my notes are like all over the place. It's so amazing. So we have -4, -1, 1, 3, 4. Okay. And our original, we had -1, 2, 2, 0, and 2. So that was my original. So now we want to double basically our y values. So if we want to double them, that means we're going to keep our 4s, but since we're going to be doubling our x's, or our y's, sorry, our new graph, yeah, I can keep it in green. Okay, so we still have our -4 for our x, but we're going to double our y values. So -1 times 2, that gives me a -2. Then 2 times 2, that'll give me a 4 because we're doubling the y values, still keeping our x values. So 2 times 2, again, we got 4 here and 4 here. And 2 times 0, that will give me 0. So if we try to plot those points onto this same grid that has my parent function, let's see what happens. So we have -4, -2. That's right here. We have 1, 4. That's up here. Then we have +1, 4. Then we have 3, 0. That remains. But then we have 4, 4. So from here to here. Okay. So it's almost like someone picked up this little part right here in the center and just lifted up. Okay. And then you notice it's not so broad, it's a little narrow. So it's almost like someone went like this, almost like to a pimple. And you know, when you try to squeeze on the sides of a pimple, what happens? All the lovely ooze, sorry for people that are eating dinner, it just kind of comes up to the top. That's basically what you're doing, okay? You're kind of pushing it in and it rises on up, all right? So now, that, since it was our a value was greater than 1, that was going to give us that stretch. So now if I try to, let me see, on the same grid, blue may not be the thing, so I'm going to try red. So if we try on the same grid for us to use 1/2, and I'm going to see if I can get right underneath. Okay, so if I'm taking half of my f of x, okay, keeping my same values, so this is my original, okay? So we always go back to the original. So after we go back to the original, we're going to take half of all of our numbers. So half of -1 is itself, basically. So if you try to take half of -1, that will give us a -1/2. Take half of 2, okay, since 1/2 of 2 is going to be 1. And then half of 0, yeah, that doesn't exist. It's just 0. So now, let's kind of take a look at this. So we have -4, 1, 2, 3, 4, and -1/2, which is right in between 0 and -1. We have -1, 1, which is right here. 1, 1. 3, 0. Notice that hasn't moved at all. And then 4, 1. See the difference? Okay. So what's in red, that is a compression. Notice it's like short and side. Some people like to call it fun size. Sure. All right. So basically your A value tells you a lot about what's going to happen to the graph. Okay, so your A value, especially right now, I'm going to get to another part that's going to happen with the A in a second. But if it is greater than 1, it's going to be stretched. If it's between 0 and 1, it's going to be flattened out and compressed. Now the last part, and then we're going to do a couple examples, deals with the A as well. What do you think is going to happen when I come up with, let's say, y equals negative f of x? What do you think is going to happen when I have y equals negative f of x? So Pog's saying flip upside down, okay? Flip over the what? If I may take it as an extension. Flipping over to what? It is going to flip, but over what? Think about back in the day when you have a playground. Or maybe if you grew up in the city like I did, someone's fence wasn't completely fenced in and it just gave you the bar. And then you just kind of rotate it. There you go. Rotate over the x-axis. So it's just like you. If you guys are lucky enough to be in gymnastics and you guys were working on the bars, okay? And then you do this rotate, roll over it. Okay, have fun with that because that was not me. Okay, you're basically flipping, or you're not really rotating, but I want to say you're flipping over the x-axis when the negative is outside the parenthesis. So if it's outside or if it's your leading. So if we take a look, we have our x. So all we're basically doing is taking our original graph and negating the y values. Negating meaning changing it using the negative. So since it's already negative, that means it's going to be positive. So we got -4, 1, still with the -1, but instead of a +2, it's going to be a -2. Same with the 1, that'll be a -2. 3 0 is going to be exactly the same. How boring is the 0? So this is your negation. So if I may use that same grid, we're going to have -4, 1, 2, 3, 4, at +1, so that's right here. I'm going to use black. Then we have -1, -2, 1, 2. Then we have 1, -2. Again, 3 0, doesn't really change. So that tells you when it's on the x-axis, it's really not going to change that much, right? So then you have your 4, -1, 2. So it's going to be here, here, down here, and up here. Okay? So when it's negative, it's going to flip over the x-axis. So when your y value is negative, what they're saying basically the f of x is negative, you're changing your y's. You're flipping over the x-axis. All right. And then what do you think is going to happen when the negative is inside the parenthesis? Let's see if you guys can see the pencil. Okay, that works. So what happens if you have, oops, good thing I wrote it in pencil. So you have the f of negative x. There you go. The axis of symmetry is the y-axis. Yep. And the x is going to be negative. There you go. So we're going to negate our x's. So we have our, sounds like a life lesson to me, but here we are. F of negative x. Okay. So we have our original. So our original is that negative 1. R2, 0 and 2. Ooh. Ever get like a weird ringing in your ear and it's like very piercing? It just happened. I don't know. I guess someone's trying to call me. All right, so that means we have our 4, we have our 1, our negative 1, negative 3, and negative 4. So if I may, all I'm doing is negating my x's. So that means I have 4, positive 4, negative 1. It's right here. Then we have 1, positive 2. It's up there. Then negative 1, 2. Then we have our 3, 0. Negative 3, 0. And then negative 4, 1, 2. So all it did was reflect over our y-axis. So if I may, I'm going to say flip over y-axis. Okay, that's your axis of symmetry. All right. Okay, so once you kind of have an idea, outside the equation, it's going to have to be positive. Outside the equation, if it's up, if it's positive, it's going up. If it's negative, it's going down. If it's inside the parenthesis, you always do opposite what you see. So if you want to do opposite of what you see, then it means if it was a plus, that means we're going to the left, not the right, to the left. If it's x minus, we're going to the right. Now, if our a is positive and it's more than 1, it's going to be a stretch. And if it's between 0 and 1, it's going to be compressed. If it's negative, it flips over the x-axis. And if my x's are the ones that's negative, it's going to reflect or flip over the y-axis. All right. Not too crazy, not too difficult. I know, not too bad on a Sunday night. So let me see if I can give you like a couple examples and you tell me how is your graph going to transfer. Okay? So I'm going to put this in black so you can actually see it. Actually, I'm going to put it in blue so you can actually see it. So if I have the equation f of x is equal to 2 times x minus 4 plus 3. See if you can tell me what is the transformation. Let me zoom that down here so I can go this way. Oops. Because I'm like practically on the edge of the table. Like, what's going on? All right. Jedi, be careful. Why is it not a parabola? Okay, Cookie's saying up 3. All right, that's part of it. What's the rest? Right 4, or 4 right, 3 up. What's missing? What's missing? Okay. Got our stretch. Now careful, it's not an exponential. Okay, this is not exponential. Why is it not exponential or a parabola? Okay, so we got our stretch of 2 units. Okay, so since our A is greater than 1, we got a stretch. Since we have x minus 4, that means we're going to the right, because we always go opposite what we see, to the right 4 units. And then we're going plus 3. That means we're going up 3 units. Okay. The reason why I'm saying it's not a parabola, because I don't have a degree or an exponent of 2. So I'm glad that you say this, because a lot of us are so used to seeing with the square. There isn't a square there. Okay? Now, but if I shift it, I can also do it like this. Oops. So if I said, I might want to do this in red. It'll come up a little bit better. There we go. So we have the f of x is equal to negative 1/3. That's not what I wanted to do. I wanted to do this. That's 7. Minus 1. What's happening with this one? Oh, thanks for sharing the live. Yes. Okay, Pog. Pog got an answer. Anyone else? Okay, I'm trying to make this into a safe space. So Pog's saying it's flipped, it's compressed, going to the right 7 and 1 down. Do we agree? And if you're not sure, remember, question marks is also a solution as well. If you're not sure what it is, just put the question mark down. It's perfectly fine. If I need to bring. Okay, Jasper's saying left 7. Okay. So the battle between the right and the left. Who's gonna win? Obscene. Why? Why is obscene? Obscene. Does it feel like we're doing something dirty? Okay. So, can't be negatives and absolute values. All right. Good. All right. So, since we have, okay, it is going to be flipped because my A is negative. All right. So, we're good with that. Okay, and since my A is the one that's going to be negative, it's going to be flipped over the x-axis. Now, and it's also going to be compressed. And the reason why it's compressed is because the number is 1/3. Anytime it's a number between 0 and 1, that's going to show that's going to be compressed. Now, in the absolute value, okay, we all know that your answer is going to be positive, but we're not solving. We are transforming. So since it's a plus 7, that means you're going to go to the left 7 units. And then the minus 1, that's your K, that's your vertical shift. So since it's negative, we're going to go down 1 unit. All right. Okay. Solving, yes. Transformation is the same no matter what the function. Okay, let's try another one. So let's see. Let me see if I can make a little bit of room. Kind of wrote a little bit too big. But let's say if we got f of x. I think you guys can see that good. So f of x equals x minus 2/3 squared. What's happening for this one in black? So which one's this one in black? So you got going to the right 2/3. Okay, what else? Anything else happening? Okay. All right, so right here, since we have my highest degree is to the second power, so we have a quadratic. So it's going to be a parabola. Now, my A, if you don't see anything there, it's assumed to be a 1. So we have a normal parabola. That means it's not stretched nor compressed. So it's just, we're not dealing with any of that. That's just a normal parabola. But the main thing is, there is a vertical shift. A horizontal shift. Okay. We're going to the right, because it's negative, 2/3 of the unit. Okay, so we're actually going on a horizontal shift, just 2/3, whatever that 2/3 is, the same thing. Okay, and I know some people were like saying, well, what happens if I have like the sine of x plus 3? And I'm like, whatever your sine wave is, what you did, which is called, if I'm not mistaken, a phase shift. It's been a minute. So Robert, correct me. But the same thing happens when you start dealing with the trig. Okay? You're still going to have a shift 3 units. Okay? But since it's a plus sign, it's always the opposite. So instead of to the right, it's going to be to the left. So that's what I'm saying. Like, if you get this basic stuff down and know how your graphs are supposed to move, you're going to be able to develop it from functions, from trig. I think this is y equals, sorry. Okay, from trig. Okay, from absolute values. Okay, you always go opposite what you see. Yep, from left to right, you always go opposite what you see. Okay, so on the mirror part, so if it is, let me see if I can get us on track here. Okay, there we go. So if your negative is inside the parenthesis, if x is going to be the negative, that means you're changing or negating the signs of your original. So my original was up here. It had -4, -1, 1, 3, and 4. So when I negated the x values, it changes the signs. So from a negative to a positive, from a -1 to a +1, a +1 to a -1, +3 to -3, and a +4 to -4. But when the y value, when it's outside the f of x, this is when your y values are being negated. So here's my original y's, or up here, -1, 2, 2, 0, 2. So now I'm going to negate them. So it's a +1, -2, 0, and then a -2. Okay, all right. Sometimes I get phase shifts. I don't know why I get phase shifts confused, because the other one is horizontal shift. Duh. Horizontally. All right. Okay. All right. Will be -3. Yeah. So 1, 2, 3. Thank you. See, I'm not too bad. All right. So Daniel, did that help out a little bit or no? Okay. So again, if the number is outside the parenthesis, you're following the direction it gives you. If it's a +2, you're going up 2, just like how we did for the red here. If it's a -3 or a minus whatever, you're going down. That's what's happening in the green here. Now, inside the parentheses, that's giving you your horizontal shifts, okay? So that means always do opposite what you see when it's inside the parenthesis. So if you have x +2, that means you're going to the left 2 units. When it says f minus 3, you're going to the right 3 units, okay? Hence shown here in the graph. Now, when your A is greater than 1, okay, so we had it doubled like we had here. That means you're going to have a stretch function. When it's between 0 and 1, it's going to be more so a compression. Now, I don't want to say all fractions are going to give you a compression. No, if it's an improper fraction, that's clearly a stretch because it's more than 1. Okay, so if it's a proper fraction, that means your numerator is smaller than your denominator, then that will be compression. So it'll be fun size, okay? And then if I already talked about the negation, and I think we're good. All right. Okay. Questions. Okay, because today was a quick one. That is a quick one. Because if you can do it through regular, linear, quadratic, absolute, you'll be able to do it if you ever get into trig, which you'll see, like, say, in pre-calculus. So, like, if you are on track, let's say you're one of those students that will take, let's say you'll take Algebra 1, maybe Algebra 1 your freshman year. So then you'll have geometry. Majority of us are still doing Algebra 1 geometry. Some states are changing. Just be on the lookout next year. It's going to be very interesting because some states are thinking, if not next year, probably the year after. I know here in Maryland, they're thinking about not foregoing Algebra 1, Algebra 2, and just place it with Math 1, Math 2, which will be a combination of Algebra 1, Algebra 2, and data analysis. So they're thinking about doing 2 years of that, and then the third and fourth year, that's when students can pick what they want for their third and fourth math credit. So if they're thinking about calculus, they can go to calculus. It's going to be a hot mess. Hi. Welcome to education. All right. So if anything, if you like my notebooks, if you want to support, that would be great. In order for me to keep this going, I know I'm going to be making this announcement more and more each time. I'm starting to look at, a little bit of analytics and everything else. So I'm trying to support as much as I can. I know a lot of you guys either like what I do or you're just like, meh, that's kind of fun and entertaining. But if anything, if you guys can support, I would greatly appreciate it. If you can gift, if you can, send your likes, share the live, that will be awesome. But here is my Ultimate Math Notebook. I have it basically designed for 7th grade all the way up to adults. It gives you a section for you to put your formulas in, as you see, and if you have any steps that you want to remember, you can put those steps in there as well. But in addition to all of this, we do have a section which is called the resource page. So if you struggle with your multiplication, instead of a multiplication table, I have what's called a factor chart. And my factor chart goes from 1 to 200. So if you always get stuck with what's the factor of, 118? Well, then let me go to 118. Ooh, crazy zoom, right? Let me go to 118 and see the factors of that. Okay, here's 118. It's 1 and 118 and 2 and 59. All right. It's not prime because I still have that 2 and 59. But if I ever had the square root of 118, I'm just going to leave it as the square root of 118 because 2 and 59 are both prime numbers as well as the 1 and the 118. All right, so it won't be able to break down, but it'll be nice so you can get this, look at it right away, and be able to transfer it. All right, then you have your rules of integers, then you have the most popular words used in most word problems, the order of operations and the properties of equations. Then we actually kind of dabbled a little bit. Then you have the different linear and quadratic equations out there, as well as properties of quadrilaterals, looking at volume and surface area, and the lovely unit circle, as well as Pythagorean theorem and some other trig functions. All right, so if you're interested, I'm going to try to get myself out of the TikTok shop. It is just not working for me. I mean, I'm going to give it a go, and I think I gave it a go just enough, but it's just really, not for my book sales. But if you are looking for some assistance with your classes, I am giving some private tutors, then also with my math notebooks. But if you are looking for a self-paced course with some weekly support, go ahead and take a look at my website at acgmathtutoring.com. I am currently trying to help students who are currently taking community college or even that want to help with the GED or the ASVAB. I'm currently going into week 3 of the course. And if you want to join in, this will be the perfect time to do it because we're just about to get into the algebraic components. So a little bit with the word problems just to get that. And we're actually starting that back up on Monday. So we see each other for another, I can't believe I'm going to say this, 9 weeks. It was supposedly originally a 12-week course. So now we're going to 9 weeks, and we're trying to hit on as many components because at the end of the course, I want you to take the GED. I want you to register and take your ASVAB. I want you to have this math ready and willing. Now, if you can't take this round, there will be another round in September in the fall. So if you're thinking about taking any of these examinations, like say in November, the fall will be the best part. So I will let you guys know in August when that's going to be and when the opening is going to be. All right, but we still are short of our goal to see if how many of these people we can support. We are just short about $600. That's all it is. If everyone just gives me $1, everything will be great. That's all it is. So anything that you can tap and then you can share, I'll greatly appreciate it. Yes, definitely. So definitely book me for the tutoring because I will break things down. Later on today, you're probably going to see a post from me to give you a small snippet. I had to wait for some people to give me approval because I don't like to just take people's information, even though I kind of have possession of it. But I still like to ask people if it's okay, if I can share their image. It's their privacy, right? And just show you a snippet of what the class looks like. Because I think a lot of people are thinking when you hear the word class, you're thinking that, oh, there's going to be 40 and 50 people in there. No, I try to keep these things small and intimate so people can feel encouraged to ask questions and to feel, and don't be like, oh, I'm going to make a stupid question. Stop. You're not a little kid anymore. Right? Those days of you really caring about how to fit in and, oh my gosh, I don't want to make a mistake because everyone's going to make fun of me. Those days are over. Okay? Just let it go. I'm the type of person that I do not tolerate rudeness. I do not tolerate belittling at all. I'm always been that mama bear type mentality for as long as I can remember. All right? So if this does sound like something that you can enjoy and benefit from, definitely reach out to me. All right. And there are a couple people that I would love for you guys. One of them is Robert. He's actually in the chat. If you have any questions about AP statistics, or if you know of somebody that's about to go into calculus or any of those advanced classes, hey, definitely reach out to Robert. He knows his stuff. If anyone ever asked me, Audrey, can you do that? I'm like, no. But I always say, I got a guy. And Robert's the guy. We finally got him on TikTok. So we're just going to let him roll with it. But if anything, we're going to work the way up. So if anything, if you have someone that's in pre-K or kindergarten that's thinking about homeschooling and they want some resources and want some support, make sure you follow my girl Nancy from Online Elementary Tutor. She is here on TikTok as well. She knows how to break stuff down, reading, writing, and even math, and she's doing a math lab this summer. So definitely reach out to her to get the components of that. Also, learning with Lynette. If you want to learn how to use the abacus, adding, subtracting, multiplying, dividing, using the abacus is more hands-on, it's more tactical. Now you can see why is 5 times 3 equal to 15. And other than you getting little things and trying to put beads in the things, all that fun stuff. But she can teach you how to do that using the abacus. And the best thing is you can use the abacus on the SAT. And now if you're doing the digital SAT, you can use Desmos, but you'll probably get to your answers so much quicker because now you have a better understanding of where the numbers are coming from. Also, if you know anybody that is going to do Algebra 2 and Chemistry next year, trust me, they always do Algebra 2 and Chemistry hand in hand. And if you need a chemistry tutor, check out Professor TK. She is amazing. She knows her stuff, and she is no nonsense. She will tell you straight up what it is, how you should do it, and just get it to the right temperature so you won't blow anything up. Also, if you're looking for someone that's doing T's, ASVAB, and also GED, and you need that during the day at 1 p.m. Central Time, okay, definitely see my girl, Miss Taylor, okay, Evelyn Taylor. So she's amazing. She's just similar to me, and I respect her the most. So definitely reach out to her. Hey, that's Kiki. Here you go. Thank you. All right. You need help for T's? All right, Kiki. Let me know. If anything, just message me and let's see what's going on. Oh, thank you, Professor TK. And then if you are also thinking about doing nursing, hey, Kiki, there you go. All right, make sure you're also following a blessed RN. She knows how to break down the dosage calculations without bombarding you with so much math. Okay, she just gets down to the nitty of the gritty. And then plus she is an active RN as well. So she's doing what you're trying to do. So why not connect with someone who's doing what you're trying to do? Okay? Yep. So if anything, these are definitely people that you want to follow. If you have any questions, do not hesitate. Do not hesitate whatsoever. But again, if you don't mind, $1, even if you give me some gifts, just so I can keep this going, so I can help support people that needs the help and they just can't afford it. We all know we're all restricted financially. It's like not even funny. Like 1 minute you think that, okay, let me see what this $50 can do. It can't do anything. It gets spent before you know it. You're like, did I just spend $50 before I walked out the house? Like I didn't. What did I spend it on? I'm telling you. So if anything, any pre-calculus helpers, yep, I can help you with pre-calc. Yep, that's my thing. If it's AP pre-calc, anything A and a P in front of it, that is Robert. Because I don't know, the terminology with AP or maybe IB, I'm not sure. Robert, do you do IB? I'm dying. Yes. Yeah, definitely reach out because I have a lot of room for my tutoring sessions. So we can figure something out so we can get it done. Because a lot of my students, they're gone officially for the summer now. So this is the first week for us in Maryland that we're actually on summer break. Like now. It's just so sad how we're like the last ones, but here we are. Okay. You do IB? Okay, good. Good. It's good to know that. Yeah, because sometimes the language is sometimes what throws me off. So, yeah. All right, good to know. All right, so let me know if you guys need anything. I am here. Yeah, I feel like, I don't know. I have a weird feeling, but I'm really happy. Oh, for those that wonder, my water did come back on. It's not on full force, but it's something. So, yeah, and it wasn't me. The city just decided they're doing a lot of construction in my area. So they just decided to turn the water off and not tell anybody, thinking that we're not going to figure it out. Salah. Makes me wonder about these people. All right. And then, if anything, definitely check my profile because I am going to be working on the summer months. Almost forgot to tell you about that. I'll be here mostly in the afternoons. I'm thinking about 1 p.m. except for on Wednesdays. I'll be here at 11 a.m. I had to do the early times because of all the other stuff that I'm doing. But if I can sneak in a late night, just pop in and just be like, hey, I'm just doing some math for you guys, I will try to do it that. Okay. Oh, I know. It's great. Oh, I will, Jedi. Don't you worry. Because, it gets kind of rank sometimes. I had to do a running I had to do one unload of laundry, but I had to run one cycle first just to get all the impurities out. So that was fun. That was really fun. All right, Fast Horse, thank you. All right, so if anything, please do not hesitate. I don't want to say desperate times call for desperate measures, but I just feel like, it takes a lot to prep. It really does. I didn't think it was going to take this much, but for me to prep, and plus I want to support people as much as I can. So if that means I put that on my back burner, I put that on my back burner because I really want to help you guys achieve your greatness. All right. Okay. So I will see you guys tomorrow at 1 p.m. Okay. God willing. All right. Have a great night, guys. Take care. And thank you so much for the love and attention and the gifts. Thank you, Jedi. I appreciate that. All the likes. Oh my goodness. I appreciate that. I appreciate everything you guys do because it's not easy. It's not easy. I'm at the point that I just have to just laugh because I don't know how my life could be so crazy in a short amount of time. It doesn't make any sense. 1 minute, though, there's, it's nice and dry in the basement, and now all of a sudden I don't have water. That's funny. Anyway. All right. I will see you guys next time. Take care now. Bye now.